Record. All right. So it is 6 o'clock. Let's pray that the projector is working. So today we're gonna go over announcements first. So first things first. Things that I need to announce. Yeah. So the IEEE Extreme or the IEEE Extreme is at the end of this month. It's a 24-hour programming competition. It's probably fun. I never tried it, but I bet it's fun. It's like you have to be an IEEE member to sign up, like the official member, not like text IEEE, but like the actual thing. It's like $35 for a student. There's a discount code online somewhere you could find. But yeah, if you're down to code 24 hours straight, you can try that. Even if you're a freshman, don't be like, man, I'm a freshman, I probably suck at it. I mean, it's probably fun. I don't know, but if you're interested, check it out. Another thing, I meant to mention this at the beginning of the year, but it's not that big of a deal. The NSA has what's called the Code Breaker Challenge. It's like a capture the flag, only more fun. It's a ransomware simulator. Basically, you're going through a made-up story of like what would actually happen if you worked at the NSA. We're going to go over one of the challenges today because it uses Wireshark, so that's very fitting. So if you're interested, it's just Google NSA Codebreaker and sign up with your tech email. I think like 6 tech students have signed up, including me. So if you're interested, you want to raise our total university score, that'd be pretty cool. So want to check that out, NSA Codebreaker. So let's get started with, why is this up? Get started with the presentation. So Wireshark. Hi, I'm John. I'm the president of ACE. Yeah, that's me. First things first, disclaimer. So Wireshark can be used maliciously. I ask that if you do it maliciously, don't get caught. We are not responsible for what you do. We're just here to teach you stuff that you could possibly use on your own. That's kind of how it goes. Right. So what is Wireshark? Well, it is a commonly used tool for packet sniffing. So guess what that means? You're sniffing a packet. If you sniff something, let's say you know those Febreze commercials? We're like, what's this smell like? It's like an old shoe. It's like, oh, it smells awesome, you know? Kind of like that. You're blindfolded. You don't really know what's in the packet. So you're going to sniff it and kind of figure out stuff about it. Get a good glimpse of what's in the packet because most packets are encrypted. They're wrapped. I should also mention what a packet is. So in the internet, words are never reused. A packet is, well, what do you think a packet is? If you send mail, remember the Timmy Turner Fairly Odd Parents episode where he had to go to the internet, and when he was in the internet, all those mail was flying around. That's kind of what packets are. It's like mail flying around. They're wrapped. So Wireshark sniffs these packets, gets like, you know, the address, quote, address, other metadata stuff in those packets, and it tells you what it is. That's what people use for Wireshark. And those fake Wi-Fi phishing honeypots, like those FBI vans that say, hey, free Wi-Fi, you know, they'll probably use Wireshark or some other tool a lot like that to sniff packets, get your password, stuff like that. What it does, it just captures inbound, outbound network traffic. Basically, if I log into a website, that's outbound traffic and inbound traffic. Hey, website over here, I want this, outbound, inbound. And Wireshark's like, hey, I found this, here you go. So why would you bother using Wireshark? Well, let's say you want to steal passwords, because who doesn't? You would use Wireshark, right? You want to make fun of how awful your friends' assignments are. You can say, ha, your PDF is stupid or something. And you want to make fun of tech's horrific printing system, which is not secure at all. Huh? Yeah, it is, because it's awful. It's unencrypted HTTP, which is terrible. Fun fact, I printed out my social security card on it, and I rapidly realized that I probably shouldn't have done that. So if you ever break into the Tolliver printer, delete that for me. Thanks. All right. Yeah, text printers are terrible, in case you didn't know that already. So in the real world, what you would actually use Wireshark for, it is an excellent logging tool. It is perfect for a network administration. You want to figure out if anything fishy happened, you know, like say, hey, we may have had a breach between, I don't know, 12 and 10 p.m. I need you to figure out what came in, what went out, stuff like that. So we'll go over kind of like a little bit of that in a minute. Malware discovery. So a lot of malware to circumvent an intrusion system, they don't send in the malware immediately. It's not like you're not going to send a malicious exe in an email. That would be caught pretty easily. But you could send something less suspicious, like a basic shell command to download from a random IP, in this case, an LP or listening post, to download more malware in to execute that. That's a lot of malware does that to get past the prevention and detection system. So yeah, let's go crack it open. I did not have a lot of time to prepare for this because I was busy studying for exams. So Wireshark, I didn't do it on the VM. We're not going to worry about Kali today. Not a big deal. So I installed the GUI because why not? Wireshark, if you Google Wireshark, you can install it on your laptop. It's not very hard. Basically, you pull it up, you get a screen like this. I hope y'all can see that. Is there a way to zoom in? View, zoom. No. All right, well, never mind. Basically, you pull it up, you get a bunch of different connections that you can use where you can capture packets. For this, we're going to use Wi-Fi because, I mean, obviously Wi-Fi. Enter haystack. After about 5 seconds, we have 1,000 packets just being zoomed through. You're like, wow, this is a lot of stuff. Everybody has their laptop open right now, and Windows machines like to talk, like to chatter a lot to other machines. So I am on Tech's Wi-Fi right now, TechX Wi-Fi, excuse me. And yeah, after there, you can kind of see, man, I wish I could zoom in. I don't know why I can't zoom in. Oh, there we go. There, y'all can see that, right? Yeah, cool. So let me kind of walk through what we're looking at here. Basically, we have the number, packet number, time since the beginning. We've already got 10,000 packets because everybody has their laptop open right now. We have the source IP address, right? Maybe that's the projector. It is UDP, that makes sense. Or it's something else. We're gonna, anyways, source IP address, destination IP, protocol, length of the data that's being transmitted over that we can see, and then information, other random stuff that we can look at. So this is a lot of stuff. Like I said, it's a haystack. So we're gonna pull up HTTP and we're gonna filter HTTP. Nothing right now. I'm gonna go to google.com because why not? So google.com, pull back here. Hey, look, HTTP protocol, right? Google.com, what it's doing is that it's sending a GET request to google.com in the root directory, GET/root directory, and then HTTP. So what we can see here is Hypertext Transfer Protocol, which HTTP stands for that. GET, host, connection, stuff like that. These are all the header information, stuff like that. A lot of stuff. And it is the 16,000th. Somebody's calling me. Excuse me 1 second. Sorry, Dad. So yeah, it's gonna get, and after it retrieves the GET, so this is my IP address, 1047, to Google's IP address, this one, GET, and then when I get the GET, it sends it back. In this case, it was a move permanently, but it forwarded me to the correct location. Sends back what I wanted, the byte information. So I'm gonna pull up what we can do in a HTTP capture situation. Let's say I'm gonna spin up a website real quick, if it'll allow me. So Python 3, y'all can't see this, can y'all? Let me zoom on in. Yep, Python HTTP server. So everything. I've got a server open on localhost port 8000. So I can pull up. Can I do? I'm going off the cuff because, like I said, I was not prepared for this. I was studying a lot. IP address. Let's go. This is my IP. So grab that to connect to myself. I probably could have used localhost, but regardless, port 8000. So this is my directory listing for my standard installation for Kali. And like here, you can see Git stuff right here. But on Wireshark, you should see, or you're not going to see, what the heck? Maybe it's not HTTP. I'm going to filter by IP address, which is I already copied it, didn't I? This. Man, this worked last night. Great. Bear with me for a second while I get this working. Why? Why are you not working? All right, Avery. Well, let's just wing it. So, no, it's HTTP. I was going to show FTP in a second, but 172.19.761. I don't understand. Come on, man. This worked yesterday. IP.adder equals this. Crap. Well, all right. Well, what I was going to show you is what it looks like. But, man, I'm upset. This worked not long ago. All right. Well, this is what would have showed up theoretically on Wireshark, but we can see it on ourselves. So we have Git, HTTP, same thing as Google. I was going to download a file and then have Wireshark grab the file for me, but that's not freaking working for some reason. Let me try this because this is probably not going to work, but we'll try it. Let me get this out of the way. I'm going to pull up a Tor site because why not? Hop into Tor and we're going to download that because that's not HTTPS. So if it was HTTPS, we would not have access to what I download because it's secure. S stands for secure. So it'd be encrypted on the way in. We couldn't grab it. So we're Tor with Tor. It's not secure. Quote. Welcome to the dark web. That's what it looks like. So what I'm going to do is filter by HTTP. Please, please pull up correctly. Son of a bitch. Maybe it's 127. Because Tor connects to yourself. Quote, quote. No, it didn't work. I am so mad right now. You have no idea. Man. Let me try. Maybe it's being stupid for some reason. Where are you? Maybe we'll try this one. Wireless LAN. Man. Come on, please. Oh, that's me. That's probably what's flipping it out because I'm connected to this thing. That's what's going on. Or I'm going through Zoom and HTTP. Please. Well, that was Google. Son of a bitch. Oh, well. Well, I could probably search for a packet by Onion. That's what I'm probably going to do. Edit, find packet. It's going to take forever to find, but .onion. Maybe I should get rid of the filters or not. Man, I am so frustrated right now because it was working not 5 seconds ago. All right, skipping ahead. We're just going to keep on trucking. So FTP file transfer protocol. Let's just skip ahead to that because tech internet, am I right? So if you want to connect to another machine to access its files, you would commonly use file transfer protocol, FTP. There's different types of FTP. There's FTPS, which is FTP over SSH, which is secure. And then there's SFTP, which is secure FTP, right? But for my case, there is plain FTP. So command for that is FTP. I'm going to go to my web host. because that is plain FTP. Cool. So connected here, yada, yada, yada. Welcome to this. The host that I use is called Nuclear Fallout Servers. Fitting. So we can go over here and filter by what is going on Wireshark. Just restart. All right, FTP. Let me try that one more time. FTP, connect, pull up Wireshark. There we go. It worked. Something happened correctly this time. Awesome. So as you can see, I tried to connect via FTP to a remote server on this internet, and Wireshark captured that, said, hey, here's an FTP protocol being sent from this machine to this machine. Cool. Well, this is actually the response. So it requested, hey, send back a login, asked for the login name, welcome. It was the welcome thing. So what we have right here is FTP, file transfer protocol, and this is the response, 220. Response 220, welcome to this FTP site. So gonna hop back into here, and my username, skag. Cool, and hop back into Wireshark. This is what I sent out. Going outwards is user blank. And then the response then is 331. That's a good code, I think. It says, hey, specify the password. So what I'm not gonna do is tell you my password, but I mean, you won't know it. So password, look what's in plain text, my password for FTP, right? So if I was actually connecting via FTP on this Wi-Fi, I'd be screwed if somebody was running Wireshark. If you do it through another, like a software program like FileZilla, it encrypts it for you. So you don't have to worry about it, quote, quote, but you're much better off using a much more secure method like FSD or SFTP or FTPS. Cool. All right. So since things just don't want to work, I was going to spin up a Netcat server, and that would work because that uses TCP to connect from this machine to this machine, but didn't work because projectors. Yeah, man, ain't that something? Anyways, so let's hop out of this. I'm going to jump into the code breaker challenge. Let me log out of this. Get out of this Tor site, which I will blur. So it's NSA code breaker. I'm just gonna Google that. Basically, like I said, it's a ransomware simulation. So I'm just gonna go ahead and redo challenge number 1 because it uses Wireshark. How fitting, right? So you're gonna use what you would learn in here if it worked, what I would show you, but we'll show you something that we can do here. Am I signed in? I am signed in. Challenge, let's pull up task number 1. Yeah. Just don't zoom in then, come on. Cool, all right. Task number 1, network forensics command line. The NSA Cybersecurity Collaboration Center has a mission to prevent and eradicate threats to the US Defense Industrial Base. Based on information sharing agreements with several DIB companies, we need to determine if any of these companies are communicating with the actor's infrastructure. Basically what they're saying is, hey, we found a bad person, an APT, an advanced persistent threat. And we're like, hey, we got to figure out if any companies were communicating with this listening post LP, like I mentioned before. So, hey, you professional hacker, cybersecurity expert, you've been provided a capture of data en route to the listening post, as well as the list of all these companies and their IP ranges. So we want you to identify if any of these IPs have been communicating with the bad people, right? So it's going to give you a capture.pcap. This is a Wireshark file. This is a Wireshark capture file. Basically, when I was running it, it had all that stuff spewed out. You could save all that to a file, but there was a trillion, so I'm not going to save all that. And download this, and then here are the IP address ranges that we're going to go ahead and look for. So I'm going to pull up VS Code because that'd be much easier to use. And we're going to pull up, we'll pull up the IP ranges first. So here are the IPs. I think it's, well, I know computer networks, you go over how IPs are created. Don't you do that at 130? go over how IPs look up? No. Yeah, I think it might be digital design. It might be digital design. We also go over these, but basically, IP address, a slash stands for the subnet bits. Basically, it's a bit mask. I'll try to explain this as best I can. It's a subnet. It's a bunch of IPs can fit in that single line instead of typing out all the combinations, possible combinations. So downloaded a Pcap file. Let's go ahead and pull that up. Double click it with Wireshark. Wireshark can open it, and it's going to say, hey, look at all the stuff I found. This was in the Pcap file. There's a bunch, but nobody has time for that. We're not going to be looking for all the possible combinations of these IPs in this file. We're going to be smart people and script it because, yeah, why not? So to do that, we should export the Pcap into a file that is human readable. Because let's say if I open it up with Notepad, it's going to go, what the heck is this? This is garbage, gobbledygook. So what we should do is export it. It is tshark and the Linux command line, which is the command line Wireshark command. So it's tshark tech R for read, and it is capture.pcap out, redirect out to capture.text. Please work. Cool. All right. So have our IP ranges, and now we have our capture file, which is a lot like what we showed up in Wireshark. So what we can do here is say, hey, here's a file that we can parse with Python, right? Because Python is easy. So we have right here, we have the host connection, the arrow, which points to what it's connecting to. So these are, we're going to be looking for everything over on this side. What was connecting with the listening post? So we're going to use Python because, yeah, Python. For this, we're going to need, let me say that real quick. I don't know, run.py. For this, we're going to need IP address, I think. That better work. Yeah, okay, we're good. So we're going to open these IPs and we're going to allocate these into a list or a set and say, hey, these are the subnets we're looking for, right? Right. We're going to scan everything in capture.text to see if any of these IPs lie within these ranges, okay? So we're gonna do some, I'm gonna be like a professor and I'm gonna code in front of you, right? Because they all do it, don't they? They code in front of you, expect you to learn. But anyway, so we're gonna do it with open IP ranges dot text as F. Hang on, I'm getting there. Let's go with networks, empty list, 4 lines in file. Let's make it a set. The sets are a lot easier. Because you know what a set is? Y'all know what that is? Where there's no duplicate values. Right, yeah, now we're thinking like a programmer. Okay, so for lines in the file, we're going to networks.add, and it's IP address dot IPv4 network, and it's line, I messed up line. So it includes the it's the new line character because Python, you know. So we're gonna splice that off, and it's gonna add, and so we can turn that to a list because that'd be easier. So we have our IPs, our IP networks, which we can see, hey, what's in these networks. So now we need to open up the capture. As F. It feels so weird to code in front of people. I had a professor do it. Anyways, so gonna iterate all the lines in here. So for line and this for line and the file, we need to, oh, before I forget, this is gonna yell at me. Strict is false because some IPs are bad. They don't like it. I don't know why, but Turn off strict, doesn't happen. So iterate every line in this file. A little bit more difficult or a little more complicated to parse. So what we want to do here is split the line into indices, index it. So at index 0, or line 1, index 0, that is the number. Index 1, this is the timestamp. Index 2 is the IP that we're looking for, right? Right. So do s equals line split. Let me strip this real quick. So we're gonna split it into an array or a list of strings. And we're gonna grab the IP at index number 2. So IP is index number 2. And IP equals IP address. IPv4 address IP. Cool. Awesome. Now we can append that to our list. Right? Yeah, that's a good idea. Let's also make this a set because that would be better. So IP.add IP. Cool. And then return that back to a list. Okay, so now we have our networks, we have our IPs. So what we want to do is back to what the first thing they wanted us to figure out, which is what IPs within this or within the networks communicated with the listening post. Okay, so I have to iterate, I have to do some math. So an easy way is make a new list empty. So we're going to iterate for IP and IPs. Go with in-list, in networks. It's false. For networks, in networks. So if the IP is in the network, that means, hey, this IP part of this network and it communicated with the listening post. This is something that we're looking for. Cool. Please work first try because I am exhausted. So that means in networks is equal to true. And if this is true, new list.append IP. And then at the end of everything, we're going to print new list. Cool terminal. Please work. Please work. I need to save the file. Run.py. This is not what I'm looking for. Let's run it here. PowerShell. Come on. Work first try for me. Yep, okay, that worked, thank God. So it printed out a list of all the IPs that we just parsed, figured out, hey, these are all the networks. So this address, this address, this address, this address, and this address all communicated with the listening post. These are all infected, quote, quote, infected machines. From there, we can figure out what to do next. So what I just did was do number 1 for the Codebreaker challenge. If you want to do that again, or you want to do it, I mean, you can do what I did, or you can just look through Wireshark at all the stuff and do it the hard way. But make your life easier. Use Python. Scripting makes your life a lot easier, whereas just staring at stuff, trying to find the needle in the haystack, it's a lot harder when you're doing it by hand. So use Python. That's all I got because I was going to do a lot more, but freaking Wi-Fi, am I right? But yeah, that's Wireshark. Challenges. There's some Wireshark challenges on the TechX site if you want to do that. This Friday at 6:30, we have a talk at TechX. Elise Jones. Yeah, Elise is going to be here. She goes to Virginia Tech. She's a grad student and she knows stuff. So if you're interested about learning, what does she do, Megan? What does Elise do?
She does augmented reality research.
Okay, that. If you're interested in that, come on down Friday at 6:30 and here. It'll probably, be a lot better than what I just did because that was a mess. So thanks for coming. I wish it would have gone a lot smoother, but technology, good luck on your midterms if you haven't taken them yet, because I know a lot of people still haven't. So yeah, this concludes the meeting. Thank you all for coming.